Thank you, and welcome to my presentation. Today I'm going to present the data mining project, which is titled as Evaluating the Effectiveness of Machine Learning Algorithms in Detecting Phishing Emails. I am Russel, and this presentation is part of the partial fulfillment of the data mining course at UTA IMC. So what is phishing emails? Phishing emails are the suspicious emails that the hackers use to get the access to people's private contents such as password, emails, photos, and bank accounts, transactions, and any other things that they can target. So that's why phishing emails are a major cybersecurity threat, and that can bring a devastating and catastrophic effect of a person or a company or even sometime a country. And traditional methods for detecting phishing are not very effective. That's why many different researchers tried machine learning algorithms to detect phishing emails. The importance of this study is that helps improve the email security by automating the detection of phishing attempts, aims to reduce false positive and improve accuracy in distinguish the words and emails from phishing. The objective of this project is to explore some different machine learning models, whether they can detect machine learning, the performance of machine learning models in detecting the phishing emails, and then evaluating those models' performance using metrics such as balance, accuracy, precision, and F1 score and such. I'll talk about that in a bit. And in this project, I have chosen NLP, linear SVM, RBF, SVM, holistic regression, and random forest as my models. So mainly focusing on model optimization, evaluation, and comparison using cause validation and hyperparameter tuning techniques. So there are some related studies. This is some of the literature reviews that I found from different searches. For example, in 2007, Abu Nima used decision trees and made base an SVM on URLs, not on the text, to identify the phishing emails. And then in 2010, Benghazi applied text mining technique with SVM for detecting new phishing companies using TF-IDF. And in 2015, Al-Ajib et al. Demonstrated deep learning models such as NLPs and CNN for text and HTML structure, so for detecting phishing emails. And in 2021, which is a very recent study in Rathod and Shah, compared deep learning models and found CNN outcome outperformed traditional models in detection of phishing emails. So there are numerous studies went on. So for my data, I use data from Kado, and the data set consists image-related feature. The features are number of words, that means total number of words that the email contains, then number of unique words, count of unique words in the email, then number of stop words such as BN and all other stop words. There is a dictionary for that. And then number of links, count of hyperlinks in the emails. That can be a very good parameter in detecting phishing emails. Number of unique domains in the emails. And then another parameter is number of email addresses present in the email. And of spelling mistake in the email. And the final one is count of urgent keywords such as urgent, limited time, etc., etc. So urgent keywords are really very good red flag for detecting phishing emails. And our Y variable, since this is a classification problem, our Y variable is 1, which says that this is a phishing email, and 0 says no, it's not a phishing email, it's a good email. So initially, the original dataset contains 524,845 data points, and I ran some models in the beginning, and it was taking too long. So one of the models took 30 hours. I had to run it and then went back home, came back the next day, and still it was running. So I came up with like reducing the data set to a practical, to a number that can reduce the processing time significantly. Then I reduced the data set to 200 data points by doing sampling. So during the data cleaning, I found some missing values such as NaN values. I removed those values, and then there was no more operation needed for this data set because Kaggle has almost very clean data most of the time. And feature scaling was applied in the beginning of the data. So some of the visualization of the data is given, correlation matrix is there. So we can find that number of total words has very good correlation with number of unique words, and number of stop words has also very good relation with number of total words. And in my report, I showed the histogram, box plots, and other. And in my code, I also ran for outliers. It was found that there are like 26 outliers. But since my data set is kind of small now, only 200 data points, I did not remove any of the outliers. So this is the principal component analysis to see which components are important in features, and that also shows some outliers in the diagram. And this cumulative explained variance ratio clearly shows that even getting first 5 features will allow me to attain like 95% of the variation in the model. And also after 6 components, 7th and 8th features are really not that important because 6th feature almost let me achieve 99% of variation in the model. Even though it shows that those are not important features, like 7th and 8th one, I still did not remove these ones because I wanted to see actually how it behaved getting all those features. So as I have mentioned, I use these 5 models: multi-layer perceptron, MOP, linear support vector mechanism, and then radial basis function SVM, then logistic regressions, and random forest. The performance metrics used was balanced accuracy, confusion metrics, sensitivity, specificity, precision, and F1 score, and also average balance accuracy for all the folds. I used 5 folds. So at the end, the average balance accuracy for the folds were also recorded. And MSE, RMSE, these metrics were not explored for this project. And cross-validation and hyperparameter tuning is very important in checking the model performance. So for cross-validation, I use 5-fold cross-validations that helps in class distribution preservation, performance evaluation, computational efficiency, and bias variance trade-off. And for hyperparameter tune, grid search CV was used. And for MLP, tuning of hidden layer size was 10. Um, um, Outer loop was 5, and there was minimal reviews. Activation function, solver and mix iteration, linear SVM, and for RBF SVM, tuning of C and gamma values were used. For logistic regression, tuning of C was used, and for random forest, an estimator, maximum depth, and minimum samples, these were tuned for performance comparison. And for results, you can see that MLP has a mean balance accuracy of 0.61, whereas the linear SVM has 50% of mean balance accuracy, and in non-linear SVM, that was found as 59%, and for logistics regression, it was 55%, and at the end, random forest gave 52% of mean balance accuracy. Then models were compared during the ANOVA. So ANOVA test revealed that the p-value is 0.007. That means it cannot, conclusion is rejecting the null hypothesis, which means that there is a significant difference between the performance of the models being tested. So we need to now find which model is performing the best. For that, we have to do the pairwise comparison of the model using t-test. So as you can see, that first pair, MLP and linear SVM, was found significant, where MLP won with a p-value of 0.001, and the third one, MLP and logistic regression, MLP performance was found significantly better than the logistic regression with a p-value of 0.045. And there are several other occasions where the other MLP won. In total, 3 significant wins was there for MLP models. So after doing the pairwise comparison, it was found that MLP, which is multi-layer perception model, was the best performing model in this project and for these data. And the conclusion can be drawn as key findings that MLP found the best with the highest mean balance accuracy across all the folds, and MLP showed significant improvement over logistic regression and random forest and linear SVM. There are some challenges though, like sensitivity remained a challenge for most models because that was not very high in any of the models. And that's the end of my presentation, and thank you very much.